Hello everyone, welcome to Chemistry Daily, where we talk about anything from reactions and bonding to nuclear matters.
Today we will be talking to you about single displacement reactions, also known as single replacement reactions.
We will be discussing what they are, how they work, where they came from, and also show you some real-life examples that you will be surprised to hear.
To start off, what is a single displacement reaction?
A single displacement reaction is a type of reaction that occurs when a single element in a compound is displaced by another similar element.
The elements that switch places must be the same type. For example, metals, nonmetals, and halogens.
The basic chemical formula for metals in a single displacement reaction is A plus B yields to B plus AC, and for nonmetals it would be A plus BC yields to B8 plus C. And finally, for halogens, the formula is A2 plus BC yields to C2 plus B8.
To put this in an easier term, imagine A is a girl named Lucy, B is a boy named Mark, and C is a man named Jonathan. Mark is madly in love with Lucy, but Lucy does not feel the same way about him. So, Jonathan comes into play and Lucy falls in love with him. Lucy and Jonathan get married and Mark is left alone.
The factor that determines whether a single displacement reaction occurs is the reactivity of specific elements. The element that replaces a new element in a compound must have a higher reactivity level in order for a reaction to occur. This means that a single displacement reaction cannot be reversed. You can refer to the metal activity series table to see which metals are more reactive than others.
For metals, there are three types of single displacement reactions that can occur. The first one is when a metal replaces a metal in an ionic compound. As you can see, copper replaces silver in this reaction. First, copper was the lone metal, and after the reaction, silver was the lone metal. Silver is the more reactive metal, which is why it was able to replace copper in this reaction. This reaction cannot be reversed because copper isn't as reactive as silver.
The second type of single displacement reactions for metals is when metal replaces hydrogen in an acid. As you can see in this reaction, magnesium replaces hydrogen from hydrochloric acid, producing magnesium chloride and leaving hydrogen alone as a gas. Due to the fact that hydrogen is a diatomic element, it is produced into a gas rather than a solid.
The third type of single displacement reactions for metals is when a metal replaces hydrogen from water. In this reaction, sodium replaces hydrogen from water, yielding sodium hydroxide and hydrogen gas.
Some of you might be wondering why halogens might have their own category. Well, the reactivity of halogens decreases as you go down the periodic table, unlike any other group.
This is an example of a single displacement reaction containing halogens. In this reaction, fluorine gas replaces bromine.
Now, let's talk about examples of single displacement reactions in our day-to-day life so you can all relate and understand them better.
Many people don't realize this, but single displacement reactions are present in the real world and have been a very significant factor in the development of modern society. In 475 BCE, ancient China, single displacement reactions were discovered. It was first used to isolate copper metal through two chemical reactions. At this time, this was a very significant discovery, as it helped the ancient Chinese create weapons such as arrows, axes, swords, and other things such as armor and jewelry.
The first reaction that they used was when cupric oxide reacted with sulfuric acid to produce cupric sulfate and water. Next, they used the cupric sulfate that was produced and added iron to it to isolate the copper. In this reaction, the cupric sulfate reacts with iron to produce ferrous sulfate and copper metal.
Another real-life example of single displacement reactions is the creation of thermite, which is used to join railroad lines together when it is heated. In this reaction, ferric oxide and aluminum react to produce aluminum oxide and iron. This reaction occurs through exothermic reaction, which is what joins the railroad lines together.
The world-famous Statue of Liberty in New York was once a brown copper color, but over time the copper reacted with the air and produced a greenish coat. The coat then reacted with the iron on the inside of the statue and rusted, forcing repairs to be made in the 1980s.
In the medical world, single displacement reactions are used to treat certain conditions. For example, people that suffer from acid reflux, which is caused by too much hydrochloric acid in the stomach, use baking soda or sodium bicarbonate to cure the illness. When the baking soda reacts with the hydrochloric acid, the sodium replaces hydrogen and produces salt, water, and carbon dioxide, which aids in the cure.
So today we've covered what single displacement reactions are, how they work, where they came from, and we've even given you some real life examples. That is all for today's show. We hope you have learned beneficial information from it. Be sure to tune in tomorrow when we talk about the mole theory.